variables, the first thing we have to talk about are what are called observational units, or individuals or cases. It's going to depend on which resource you look at. But it's basically the thing or the person that you're measuring. And we're going to ask you that question a lot because variables and observational units are different things. The observational unit is who or what you're measuring, but the variable is that trait for that person or thing. And the way that I always tell students is a variable is going to differ from person to person, or it's going to differ from thing to thing. And that thing that it differs from, that's your observational unit. So height is a good example. Height is a variable because it varies from person to person. And so it's persons or people, that's your observational unit. And height is your variable. Now, a variable has to differ from person to person. So, or you have to have a different variable, such as color has to differ from car to car. If something is the same for everyone, it's not a variable. It is a constant. Now, there are two main types of variables. One is quantitative, and the other is categorical. So quantitative is numerical. That means it requires a number. And specifically, it denotes a quantity. And I say that because a lot of people think, okay, if there's a number, it's quantitative. If it's not a number, it's categorical. Well, that's not necessarily true. Quantitative means it has to denote a quantity of some sort, a certain amount. And I say that because, well, here's an example of a categorical variable that could use a number. Let's say zip code. Everyone has a different zip code because of the town they're in, but your zip code does not denote a quantity. So for example, out in California, the zip codes are 9,000 something whatever. Well, in their town, there isn't 9,000 of something. It's just, that's just the code they have. So a non-numerical or non-quantitative variable. So you got to be keen on the idea of denoting a quantity. Now under quantitative, you have discrete and you have continuous. Now if you have discrete, there are gaps between two numbers. And this is usually if you have whole numbers only. If you only allow whole numbers and exclude decimals, then it's discrete. But if you allow decimals, then you're going to have continuous quantitative variables. Now under categorical, there's also binary. And this often comes with things like true, false, or male, female. Things that only have two possible outcomes, we divide them into binaries. And then the last thing is the research question, and that is the question the data is used to answer. Because we're gathering all this data for a purpose. And whatever that purpose is, that is our research question. And we'll get into research questions in a few days. So let's do some examples of determining what each variable is. So for each one of these, we're going to classify each of the variables as categorical or quantitative. We also want to identify the observational unit for each variable. So the first one, whether a spun penny lands heads or tails. Okay, so if it lands heads or tails, neither one of those is a quantity, so that is a categorical. And this is another example of binary. Okay, so that is the type, but what is the observational unit? There's a different color for that. Well, whether it lands heads or tails is going to differ from what to what. It's going to differ from, or some will say penny to penny. If you flip a bunch of pennies, it's going to differ, but it doesn't say that. It says a single penny, and then it's spun a bunch of times. So it's going to differ from spin to spin. So each observational unit is each spin of the penny. That is the observational unit for this variable. So the next one, whether or not a person washes his or her hands before leaving a public restroom. So, someone leaving a restroom, you ask this person, did you wash your hands? And, well, this is only a yes or no question. So this is categorical, and again, it is binary. And so the answer is going to differ from, well, it's going to differ from person to person. So person or people. And we often want to clarify this as much as we can. So it's not just any people, but personally people leaving the public restroom. Because not everyone is going to answer this question. You grab someone who's entering the restroom, they're not going to answer it because, well, they haven't washed their hands yet, or not, as the case may be. Number of calories in a fast food sandwich. Well, this is denoted by a quantity. There's a certain quantity of calories in each sandwich, but each sandwich is different based on what sandwich it is. So the sandwich, that is the observational unit, because the calories differ between them. Next one, life expectancy in a country. So life expectancy we denote with a certain number of years. So that should be quantitative up there. Let's fix that. So let's hear quantitative here. And so life expectancy is going to differ. Well, is it the same across the world? No. In the Western countries, it's higher. In other countries, third world countries, it's going to be lower. So it's going to differ from country to country. So that is the observational unit. We go to each different country and ask them their life expectancy and see how they differ. Next one, whether an American household owns a cat or does not own a cat. So the question is, do you own a cat? Yes or no. So this is a categorical binary. You either do or do not own a cat. Now this answer is going to differ from, well, what are you interviewing? You're interviewing households. So that is the observational unit. Next one, the number of words on a vocabulary list a person can memorize in 20 seconds. So we give you a list of words, you have 20 seconds, how many can you memorize? This is a quantity. So this is a quantitative variable. Now that's going to differ from, well, does it depend on the words? No, because according to this, it says the list. So it's the same words. So it differs from person to person. And in this case, the person memorizing the words. Next one, whether or not a person agrees to become an organ donor. So, do they or not? So a simple yes or no. So this is categorical. Binary. And the answer is going to differ from person to person. And this is going to differ from each person being asked to donate. Next one, a candidate the American votes for in the 2008 presidential election. Well, this is categorical because we don't vote by number. And I do not know off the top of my head whether there were only 2 candidates or whether there was an independent running in 2008. So since I don't know, I'm not going to say automatically that it was a binary variable. But that's going to differ, what they picked, from person to person, specifically the person voting. Next one, whether or not a newborn baby tests HIV positive. So you either test HIV positive or negative, so that is categorical binary. And that's going to differ for each newborn tested. Next one, the running time of an Alfred Hitchcock movie. Well, we measure that in minutes, and that is indeed a quantity. That is quantitative. But the running time is going to differ from movie to movie, specifically Alfred Hitchcock movie. That is the observational unit. Next one, the age of an American penny. So each one is going to have a certain age, so that will be quantitative. And what is the observational unit? American penny. Because it differs from penny to penny. The weight of an automobile, we measure weight in pounds if you're in the United States or kilograms if you're anywhere else, but either way it is quantitative. And it's going to differ from car to car. I won't say automobile. And last one, how much ice cream a person scoops into his or her bowl. Well, we measure that either by volume or by weight. But either way, that's a quantity. So that's quantitative, and it differs based on each person.